we believe this is a very sensitive coastline. The shoreline is already reached the infrastructure. After we talk about a 5-meter structure, you can imagine if you put a 6-kilometer pier, how everything changes.
Lo que antes eran grandes playas en Progreso, Yucatán, en algunos puntos el mar se ha comido en el último año hasta 50 metros de playa. Expertos explican que es una mezcla de cambio climático, aumento del nivel del mar, nortes y huracanes, pero también errores humanos, como las construcciones sobre la duna costera y las obras improvisadas que aceleran el daño.
The northern Yucatan coast, basically like a low laying area, low elevation everywhere. The system mainly consists of the sea, the beach, and also the wetlands. We have a very shallow shelf. Every time you see any obstacle, that could be a port, could be a groin, or could be somewhere at the beach, the sand starts getting trapped into this very persistent and longshore transport. So we can imagine this like we have a river flowing from east to west in front of our coast, and if we put any obstacle, it will be like putting a dam in a river where the sediment gets trapped, and therefore we have a lot of erosion problems in the downstream.
But what if we could target where the sediment settles? This project explores a small-scale response to that disruption. Standard circular pier columns disturb natural currents, causing sand to be washed away and reducing the amount of sediment that reaches beaches down the coast. When we attach one vertical vane, rotated at 40 degrees to the dominant current, we can see how flow and the sediment it carries becomes angled towards the shore. Suspended between two pier columns, this prototype uses angled vanes to redirect near-bed currents rather than stopping them. Instead of blocking sand, the vane gently steers flow, slowing water in the lee and allowing sediment to settle where erosion would otherwise occur. Measurements are taken every completed tide cycle at low tide. Sediment pins, secured below ground by screw piles, record how the seabed rises or falls over time. Flow velocity is measured upstream, in the wake, and in the lee to determine how current speed affects deposition. In the end, the rotated vanes reduced near-bed current speed in the wake zone by 30 to 45%. This slowing of the current produced sediment deposition in the lee zone in a range of 30 to 40 millimeters over one tide cycle while producing minimal scour around the base of the column. The outcomes show that small, adjustable vane systems can potentially influence coastal erosion, and that with more testing, they offer a promising direction for future, low-impact interventions along vulnerable shorelines.